Now in this video, you want to find the limits of the following functions, all right? So you have the first one to be limit as x tends to infinity of 1 over x minus 1 million. Good. So let me put down the first one. This is our solution anyway. So you want to look at the limit as x increases without bound, right? That's what it means when you say x approaches infinity, just an increase without bound, not actually a particular real number. Good. And again, if x is approaching infinity, it means that x is bigger than any real number you can give to it, or you can compare with it. Good. So this is 1 over x minus 1 million. That is, it has six zeros. So look at this. As x is approaching infinity, said earlier that we are talking about a number, or x is bigger than any real number. So that means as x is approaching infinity, that means that this place will be bigger than this 1 million, all right? Irrespective of how big this number here is, as x is approaching infinity, it charges past that number. So that tells us that in the end, we are going to enter with 1 over a very large number minus 1 million. The result is still going to be infinity, all right? So we're going to enter with something like this. Good. And that gives us 0 as an output. Right? Because we said that whenever denominator of fraction increases without bound, the result of the fraction is going to be 0. So that is what it gives us from the first question. All right, let's look at the second one. We had in our last video, we were looking at some functions where their power will just to power n and some stuff like that. Those were general form of functions that we'll be having as x tends to infinity. We were looking at how the function behave. So look at this. This is the limit of 2 over square root of x squared plus 2x as x tends to infinity. Well, if we try to look at it as a substitution, let's just say we plug in infinity in place of x and then see what that gives us. We will see that we're going to have 2 over, well, when we have infinity, all right, in place of x, and we square that, if we square a very large number, the result is going to be very large, okay? But infinity here denotes largeness of something. So maybe I can raise this to power 2. So infinity raised to power 2 is still infinity, right? So there's no point for that again. Then we add it with 2 times infinity is going to still be infinity, right? So in the end, in the denominator, we're having square roots of infinity plus infinity. Well, that's still infinity because, as I said earlier, that infinity is not just a number, rather it's a fact. It tells us increment, all right? Good. So 2 over square root of infinity, the result there is going to be 0. Because square root of a very large number is going to be still very large, all right? If you're having a small number, the square of a small number is smaller than the square of a large number. So as this one is an increase without bounds, you can't even measure it. So the square root will still be immeasurable. Then 2 over that will be 0. Good. Okay, great. All right, so that tells us that the limit of the first question is 0, and then the limit of the second function is also 0. Okay, all right, thanks for watching. Please subscribe to my channel.